Good morning, students and parents, if you're watching. This is just a video to recap the things that we have done this week in class so that if there's any at-home students wondering or questioning the things that we're working on here with in-person, this video will hopefully outline that for you. Also, if you're an in-person student, you may need to watch this stuff over again so that you can maybe have a little bit of a clearer idea of what it is that we are working on. We're going to continue to work on these things, but we're going to change just a little bit. We've been working on primarily series circuits. So with everything that we do in this class, the way that I try to set it up anyway is I try to give you the information first, which is going to be through a lecture or through you doing some work on today's class, for example. So we did those series circuit quizzes. We went over all the circuit information, the rules of a series circuit. I presented all that stuff to you. Then I had you answer the series circuit discussion. That's where you got on today's class and you did those digital experiments where you were dragging and dropping the meter leads around on the screen. So that was just practice. But all of that stuff is theoretical. So when we are trying to do something in theory, we also want to prove that theory to make sure that we understand. So in addition, I had students do these two just worksheets this week. So worksheet 1, you did that, you completed it, you turned it in. And then you did another one yesterday as well, worksheet 2. So these, again, are theory. Everything that we can prove on paper is just making sure that you understand the math and the formulas behind figuring out some calculations like Ohm's law, total resistance, total amperage, total circuit current flow, and then voltage drop, which is what we are going to demonstrate in this video. So we started on this on Tuesday, I believe. I had the class build circuits based on the diagram. Get positioned here where we can see the diagram that I put on the board. And then I had them, after they got their circuits working, do a little soldering on those circuits so that they didn't fall apart. And then we started measuring voltage drop. So we measured voltage drop in 5 different locations. And the goal is to understand, number one, what's good and what's not good in regards to voltage drop. So some of these numbers, and I'm going to demonstrate in this video, some of these numbers, or some of these voltage drops, I should say, should be showing voltage drop where we're using or losing voltage, and some of them should not. So, for example, the first one that we're going to look at is going across the switch. The switch is not a resistor, so the switch should not be using or losing any voltage. Excuse me. Now, switches can go bad, and when that happens, the little contacts inside of them usually develop high resistance, and at that point, then you may have some voltage drop across the switch, but that's not normal. So this is proving everything that we have done in theory, on paper, or digitally if you're an at-home student. So I'm going to set this up where you can see it. So we've got our circuit here, just powered by a basic 12-volt battery. We've got a fuse, which you should always put in a circuit. We've got a basic switch. We've got a relay, which is something new that we've been discussing, an electromagnetic switch. And then we've got 2 light bulbs, and the light bulbs are different. They have different resistance values, which means that one is going to be brighter than the other. Okay, so we'll set this up where you can see. So we've got our battery connected. We turn our switch on, and our light bulbs illuminate. All right, so the voltage goes in here. This is where the positive side of the battery connects, and then this is our ground over here, this lead. So these 2 bulbs are connected together in series. This relay is connected in parallel. So what we're going to do is we're going to measure the voltage drops across all of these devices one at a time. So our first one is going to be right here. Our switch has 2 points of entry. So we have voltage going through the fuse, going into one side of our switch. When we turn our switch on, the voltage transfers from one side of the switch to the other side of the switch. So this is not a workload. We should not have any resistance in this circuit or this portion of the circuit. So we should see almost no voltage drop here. If we have any voltage drop at all, it should be maybe 1/10 of a volt, very, very small. In this entire circuit, we are allowed to lose a certain amount of voltage. So you are allowed to lose up to half or 0.5 of 1 volt. So if we're going to lose anything, we may lose a small, very tiny, minute amount here, but it should be very, very close to 0. Same thing goes for this relay. This relay is an electromagnetic switch. So it has a switch inside of it, and you can actually hear it clicking. So we should lose maybe another, 1/10 of a volt or 0.05, half of a tenth across this switch. But it should not be excessive. All right, get the meter set up. Set it here where everybody can hopefully see the numbers. Try to get it propped up here. We're going to set this to volts, DC. All right. So you should be able to see the screen. Now, anytime that you're measuring voltage drop, the circuit has to be active. It has to be turned on. So, first thing that we're going to do is we're going to measure our source voltage. We're going to see how many volts this battery has available. Because in a series circuit, the rules say all your voltage drops should add up to equal what your source voltage is. So we're going to measure from here to here. Okay, and we've got right close to 12 volts. Now this is something else that I've been telling students. So when we do these little worksheets or when we do stuff on today's class, generally we're going to use the number 12. In reality, a battery is actually 12.6 volts when it's fully charged. So this battery is actually very, very low. And it's not an even number. It's 11.97. So anytime that you're dealing with decimals, you have to keep in mind that you are probably going to have to round up or down a little bit. So we're going to round this up to 12. 11.97 is very, very close to 12. That's what we're going to call it. All right, so we're starting out with 12 volts. Now, we're going to turn our circuit on. Okay, bulbs are on, so you should be able to see those nice and bright in the video. So the very first voltage drop is going to go across this switch. So we're going to take our meter leads, and anytime that you're measuring voltage drop, you're going to measure essentially from positive to positive. You're going to measure across the device that you're trying to test or measure voltage drop. Now, if this switch is good, like I said, the numbers on the meter should be very close to 0. And you can see they're bouncing around right now. But once I touch them, they're going to kind of calm down. Okay, so here we go. I am touching the leads across this switch. And you can see if this was a perfect connection, then it would be all zeros. But you can see it's 0.003. So that's 3 thousandths of 1 volt. That's almost nothing. Very, very minute amount of voltage, but there is some loss there or some voltage being used there. So we have to take that into consideration in our circuit. And we also have to take into consideration that the longer we leave this turned on, the battery voltage is going to start to go down, so our bulbs may get dimmer. All right, so next we're going to measure the voltage drop across the switch in the relay, which are going to be pins 30 and 87 of the relay. Okay, so we should see pretty much the same reading if that relay is in good working condition. Maybe a little bit more. It could be as much as 0.1, which would be um, 0.100. This meter has 4 digits. Some of them only have 3, so this one's a little more accurate. All right, so we're going to move our leads. We're going to come over here, and we're going to measure pins 30 and 87. Okay, so this is pin 85 and 86. This is the control coil of the relay. We're going to switch these around. All right, so this is pins 30 and 87, and you can see our number went up a little bit from our previous. So we're sitting on 0.012. So it's a little bit higher than our actual mechanical switch, but it's still well within our reasonable expectations. As long as it's less than or equal to 0.1, then it's okay across a connection, across a point in the circuit. All right, so we've now measured 2 voltage drops across 2 different switches. Neither one of these are workloads. Now we're going to measure voltage drop across our bulbs. And our bulbs are different. Since our bulbs have different resistance values, that means, turn this off for a minute, that means that our one bulb is going to be using slightly more voltage than the other. So if we had both bulbs identical, if both bulbs were exactly the same, and we had 12 volts, that means that 12 volts would get shared or divided up evenly since both bulbs are identical, which would mean each bulb using 6 volts. But that's not going to be the case, as you're going to see. One bulb is a little bit brighter, and I'm sure it's hard for you to see that on video, but this bulb right here is actually a little bit brighter than this bulb because it has a different resistance value. What that means is this bulb is using or has more current going through it. So if it has more current, it also has more voltage going through it. So one of the bulbs, this one right here, is going to show more voltage drop than this one. But both of them added together should add up to equal what we started with, which was very, very close to 12 volts. All right, so we'll measure our battery voltage one more time. And we're still on that 11.9. It was 11.97, but since we've had the bulbs on, it has drained the battery slightly. So we'll just call it 11.9 now. We're down about 1/10 of a volt. All right, so first we're going to turn our switch back on, turn our bulbs on, and to measure voltage drop across this bulb, we're going to go, these are in series, so voltage comes out of the relay, current comes out of the relay, and it goes into one side of the first bulb, and then it comes out that side of the first bulb and into the first side of the second bulb, and then it comes out and goes to ground. So we're going to measure between right here and right here. And this bulb is saying 5.631. All right, 5.63. It's kind of bouncing around a little bit. I got kind of hard to hold this down. All right, so we'll just call that 5.63. 5.63. All right, so I'm going to write that down. Okay, so we've got a source voltage of 11.9, and our first voltage drop that is actually using a good amount of voltage is 5.63. Now, we're going to measure the voltage drop across the next one. So we are going to go, stay out of the way here. We're going to go from right here to right here. Okay, and just like I said, this one is using just a little bit more voltage. The number is slightly higher. So 6.18. Okay, 6.180, 6.18. So that one is a little bit brighter. It's using slightly more voltage because it has slightly less resistance than the first bulb. Okay, now the rules of a series circuit say that all voltage drops should add up to equal source voltage. So we also have to take into consideration we were using a very small amount of voltage here. So our switch was actually using 0.003, I believe it was, very, very minor amount. And then our relay, the switch inside of this, was 0.012. Okay, so here I have all of the voltage drops written down. So our first bulb, the one that's a little dimmer, our second bulb, the one that's a little brighter, and then both of our switches in the circuit are using a tiny amount. Now we're going to add all these together, and that number should be very, very close to our source voltage. Now keep in mind, we may have to round up or down a little bit because we're dealing with decimals. All right, so if we add all these numbers together, here's what we've got. 11.825. All right, so 11.825 is reasonably close to 11.9. It's a little bit less, and there's a few other places that we could measure voltage drop to see where the rest of that voltage is going. You can't see it on film here, but this wire is about 2 feet long, and the connections are not very good. They're just kind of twisted together. Same thing goes for the positive connection over here on the fuse. This is an equal length. It's about 2 feet. So I would bet that we're losing a little bit of voltage there. These are not soldered connections. And then also our fuse. We've got 2 connection points here. We didn't measure any voltage drop across that, but I would bet that we're losing 0.00 something across this connection as well. So if we add those things into the circuit, it's going to be even closer to that 11.9 volts. All right, so voltage drop, very, very important skill for everyone to be able to understand. Anytime that you have a problem in a circuit, if you have a bulb that doesn't work and the battery's good, if you have one bulb that's super dim and one bulb that's super bright, that's probably not correct. The most likely cause is unwanted high resistance in a circuit. The easiest way to measure for that is to do a voltage drop test, and that's why we're practicing these things. Very, very common on starting circuits of cars. Cars crank over slowly. Always remember that we're using light bulbs because you can see them working. They're very, very easy to understand. It's either on or it's off, or it's very dim or it's very bright. But there are plenty of other components on cars that you can't necessarily see working. So you may have to do these tests in order to diagnose the problem. Now we're going to be moving on next week to parallel circuits. We're going to do the same thing with these bulbs, but we're going to wire them differently. So we're going to use the same components. We're going to use the same bulbs, the same relay, the same fuse, the same switch, but we're going to connect them differently. We're going to connect them in parallel. One more thing that I'll show you, a series circuit, one of the rules of a series circuit, just like a Christmas tree light, anytime that you have a problem in a series circuit, it's going to affect the entire circuit. So we'll turn this on. All right, your headlights and taillights on your car are always wired in parallel. So right now, both of these bulbs are on. If this bulb blows, it's going to make this bulb go out because it breaks the connection to ground. Okay, so series circuits, anytime something happens to the circuit, it's going to affect the entire circuit. There's nothing wrong with this bulb right here, but this bulb is blown. Well, actually, I just unplugged it, but that's simulating a blown bulb. It's breaking the ground point. There's only one ground path in a series circuit. Now, a parallel circuit is not that way. In a parallel circuit, each bulb is completely independent. So if one bulb has a problem, it's going to be unaffected by the other bulb or any other part of the circuit. Okay, so next week, moving on to parallel circuits. If you did not complete those worksheets, or if you did and you forgot to turn them in, make sure that you give those to me so that I can review them, make sure they're accurate, and put a grade in Infinite Campus. Infinite Campus is up to date as far as grades go for this week. There should be about 5 different things in there. So if you are missing those things, make sure that you get them done. You've got the meter reading discussion on Google Classroom. You've got the series circuit discussion on Google Classroom. You've got the first 2 quizzes of Unit 1 in today's class, and now you've got these 2 worksheets. So those are the only things right now that have been assigned for you to turn in. If you have any questions about this stuff, please let me know. If you have questions about these worksheets, I would be glad to sit down and help you. Helped plenty of students this past week. It can be a little bit confusing, but it's not as hard as some students make it out to be. It involves basic math, basic multiplication, division, and addition, and occasionally subtraction. So, hope everybody has a good weekend, and I look forward to seeing you next week.